So practicing all of section 4.4, we started with given a point that's on the terminal side of theta, which is in standard position, which just means initial side here. Theta is whatever, that angle that opens from there. Find the exact value of all 6 trig functions of theta. So if you're given an ordered pair, you're given x and y. First thing you should do is consider which quadrant that's in. So if you plot the point 12, negative 13, you're in quadrant 4. And the only thing you need to find all the trig values is r. So 12 squared plus 13 squared is going to equal r squared. Oh gosh, this is kind of a large value. So I was thinking this was a triple, but that would be if r was 13. So anyway, so 12 squared plus 13 squared, 144 plus 169 is r squared. So 313 square root of that will be r. Okay. And then we need to find all 6 trig functions. So sine of theta is equal to negative 13. It's going to be over radical 313, and then we're going to need to simplify, rationalize, I mean. So let's just rationalize like this. Cosine of theta, same idea. It's going to be x over square root of 313. So let's just rationalize. And tangent is going to be y over x. Okay, and then cosecant, the reciprocal of sine. This was negative 13 over radical 313, so it's going to be negative radical 313 over 13. Secant theta is going to be radical 313 over 12. And cotangent is going to be negative 12 over 13. I guess I didn't need to plot where this point was, but the reason that it might be helpful is just to allow you to double check that the correct things are positive and negative, but otherwise that's not too bad. Okay, so I'm not going to sketch this one. Well, I'll sketch this one up here. So negative 2, 3 is in quadrant 2, just as a way to check. So we have x and y. So x squared plus y squared equals r squared. R is radical 13. So sine of theta is going to be y over radical 13, which I'm going to rationalize again. Cosine theta is going to be x over radical 13, which I'm going to rationalize again. And tangent of theta is going to equal y over x, negative 3 over 2. The reciprocals are just flipping everything. So radical 13 over 3, negative radical 13 over 2, and negative 2/3. Okay, and then x, y, and r is square root of x squared plus squaring the negatives makes the negatives go away. Squaring a square root just makes it 5. So that's radical 14. Sine theta, now this is a little bit ugly. It's negative radical 5 over radical 14. I can't simplify 5 over 14, so I just need to rationalize. So that's negative square root of 14 times 5 is like 10 times 5 plus 4 times 5 using the distributive property. So 50 plus 20 is 70. And then that would just be over 14. Oh, sorry. No, yeah, over 14. Because I multiplied by radical 14 over radical 14. And radical 70 doesn't simplify. Cosine theta is negative 3 over radical 14, so I will rationalize that. Tangent of theta is negative radical 5 over negative 3, so that's going to be positive. So no negative in there. Erase that so it doesn't look negative. And then the reciprocals. I'm going to reciprocal my final answer here so I don't have to rationalize or simplify this again. So 14's on top, radical 70's on the bottom. So it's going to be negative 14 radical 70 over 70. And that can reduce. It can reduce by 7. Negative 2 radical 70 over, you can reduce by more than 7, but that's fine. I'll do it in stages. Negative radical 70 over 5. So I could have reduced by 14, I guess. All right, and secant theta is equal to, so this was negative 3 over radical 14, so it's going to be negative radical 14 over 3. And cotangent is going to be 3 over radical 5, so 3 radical 5 over 5. All right, given the value of one trig function of theta, find the remaining 5 trig values. So here you do need to know which quadrant you're in to get the signs, the positive and negatives, right? So sine of theta equals 1/5. Remember, that gives us y and r. Sine is positive. Cosine less than 0, so cosine's negative. Think about all students take calculus. Sine's positive and cosine is negative in quadrant 2. All right, so when I need to find, I have y and r, when I need to find x in quadrant 2, I need to make sure that x is negative, right? Because over here it's negative xy. So x squared plus 1 squared equals r squared. X squared is 24. So x is negative, square root of 24 is 2 radical 6. All right, so we already had sine theta. Now we need cosine theta is equal to x over r. Tangent of theta is equal to y over x. Now when you multiply that, you get radical 6 on top, and then you get negative 2 times 6, so negative 12 on the bottom. The cosecant of theta is 5. That's the reciprocal of 1/5. The secant of theta is 5 over negative 2 radical 6. So that's 5 radical 6 over negative 12. And cotangent theta, flip this one, you get negative 2 radical 6. Number 5 says secant of theta equals 3. Make it 3 over 1. Theta is between pi and 2 pi. So here's pi, here's 2 pi. So we're either in quadrant 2 or we're either in quadrant 3 or 4. And secant being positive also is saying cosine's positive. We're in quadrant 3 or 4, so that only happens in quadrant 4 out of those two. So secant is r over x, or cosine is 1/3, however you want to think of that. So 1 squared plus y squared equals r squared. Y squared equals 8. Y equals 2 radical 2. Now is it positive or negative? If we're in quadrant 4, when you're plotting points, every y value is negative. So negative 2 radical 2. And then we go through and find our stuff. So sine theta is y over r. Cosine theta is the reciprocal of 3, 1/3. Tangent of theta is y over x. X is just 1, so I'm not going to write over 1. And then cosecant theta is 3 over negative 2 radical 2. Rationalize that. Negative 3 radical 2 over 4. We already have secant. Cotangent theta would be 1 over negative 2 radical 2. Multiply that by radical 2 on the top and the bottom. You get radical 2 over negative 4. Tangent of theta equals 0, and theta is between pi over 2 and 3 pi over 2. So that locks us into either quadrant 2 or 3, and tangent's equal to 0, so we're actually not in a quadrant. We've got to be right here. Tangent is y over x, so tangent is 0 when the y coordinate's 0, so we're actually using this coordinate where x is negative 1, y is 0, r is 1. So sine of theta is 0. Cosine of theta is negative 1, the x-coordinate. We already have tangent. Cosecant of theta, the reciprocal of 0 is undefined. Secant theta, the reciprocal of negative 1 is still negative 1. Cotangent theta, the reciprocal of 0 is undefined. Last one of these, cosecant is undefined, and we're between 0 and pi. So we're locked in between quadrants 0 and 2. cosecant's negative when you have, let's see, r over y. So when the y value is 0, the y value is 0 at both of these angles. Oops, so I'm going to need to fix that. I'm going to say just less than pi. So I want the angle to be 0 because the y coordinate's 0 here and here. So let's go with this one. All right, so sine theta, the reciprocal of undefined, is 0. Cosine theta is the x-coordinate over here, which is 1. Tangent theta is y over x, which is 0. Cosecant we already have. Secant theta is equal to 1, reciprocal of cosine. And cotangent theta, reciprocal of 0, is undefined. Find the length of segment AB. So A and B are directly below each other. So if I knew the y-coordinate of A, which is r times sine theta, I'd be all set. I would double that y-coordinate and I'd be all set. Okay, so theta, though, wraps all the way around here. So how about this? I'm going to have to find the r sine theta at this value. Now, when I do that, it's going to be negative. But I'm just talking about a distance, so I'm just going to make this a positive distance. So what is r? R is 12. What's the sine of 5 pi over 3, which connects to this terminal side? Okay, this is a speed quiz unit circle question. What's the sine of 5 pi over 3? Well, it's going to be negative because you're in quadrant 4. And the sine of pi over 3 is radical 3 over 2. So the y-coordinate is, if I simplify this, negative 6 radical 3. We want distance between A and B, so ignore the negative. We're just going to make it positive because we're talking about a distance. So 2 times y is equal to 12 radical 3. AB is equal to 2 times y. And I've put an absolute value around that just to say I'm making it positive no matter what. What about this point? So theta connects to this side here. So let's just talk about this. Now, these 2 points are a horizontal distance across, so that's going to give you an x value. X is r times cosine theta. So the radius is 4 centimeters. And then I need cosine of 5 pi over 4. Okay, so cosine of 5 pi over 4. We're in quadrant 3, so it should be negative. Cosine of pi over 4 is radical 2 over 2. So that's negative 2 radical 2. And then the question is, what's the distance between A and B? So AB is equal to 2x, and make it positive because we're just talking about a distance between. So 2 times that is 4 radical 2. Lots of our AP Classroom problems use this idea, r sine, r cosine. So make sure you go back and look at those if you missed a lot to see if you can figure out where you were going wrong. All right, we have another practice speed quiz. So here we go. I'm going to put in my ordered pairs. I have videos for all of these so far, so if you need a lot of practice on this, make sure you go through and follow along with the videos because I explain it and go a little more slowly. But here's about the maximum amount that I would write down to prep myself for any speed quiz. You have to know those coordinates to be able to do the rest of this successfully. Secant is the reciprocal of the x value at pi. The reciprocal of negative 1 is negative 1. Cosine is the x value at 150. So this is really 30 degrees in quadrant 2. Remember that all students take calculus thing. So what's the cosine of 30 degrees? Radical 3 over 2. And should it be positive or negative? In quadrant 2, cosine is negative. Secant is 1 over x. So what's the cosine of pi over, what's the x value at pi over 3? 1/2. Flip that, it's 2. And you're in quadrant 3, so secant and cosine are negative in quadrant 3. Sine of 90 is the y value at 90, which is 1. Cosine of 7 pi over 6, you're in quadrant 3, so the answer is negative. What is the cosine of pi over 6? X value there is radical 3 over 2. So I did that in a slightly different order. You can do it this way. Tangent of 315, that's quadrant 4, so tangent's negative. What's the tangent of 45 degrees? 1, so negative 1. The reciprocal of the y value at 180, well, the y value is 0. The reciprocal of that's undefined. The x value at pi over 6 is radical 3 over 2. The y value at 2 pi over 3, you're in quadrant 2, so sign's positive. What's the sign of pi over 3? Radical 3 over 2. Reciprocal of the x coordinate at 330, so you're in quadrant 4, secant and cosine are positive. You should be looking at the 30-degree angle to get your value. So the x value there is radical 3 over 2. Flip it. It's positive. Rationalize it. That's your final. Cosine of pi over 4 is radical 2 over 2. 5 pi over 4 is in quadrant 3, so make it negative. Sine of 225, you should be negative in quadrant 3. Sine of 45 is radical 2 over 2. Tangent of pi over 4 is 1. The x-coordinate at the bottom of the circle is 0. X over y for 60 degrees. X over y is 1 over radical 3. Quadrant 1, so it's positive. Rationalize your answer. Sine of 3 pi over 4, you're in quadrant 2, so it's positive. Sine of pi over 4 is radical 2 over 2. Tangent of 135 is in quadrant 2, so your answer is negative. What's the tangent of 45 degrees? 1. Sine of pi over 3 is the y-coordinate there, radical 3 over 2. Sine of 210 is in quadrant 3, so it's negative. What's the sine of the 30-degree angle? 1/2. Cosecant of 270, so that's the reciprocal of the y value at the bottom of the circle. The y value is negative 1. Reciprocal of that is also negative 1. All right, and then the last thing we did in 4.4 is find the angle. So without a calculator, give all answers within one full circle. So this is where you think about reference angle. What makes cosine radical 2 over 2? Pi over 4. What quadrants is cosine negative in? Quadrants 2 and 3. Theta is equal to the pi over 4 angle in quadrant 2 and the pi over 4 angle in quadrant 3. Where's tangent undefined? That's y over x, so it's where x is 0. So think about your 4 points here. At the top and the bottom of the circle, the x-coordinate is 0. So no reference angle for this type of problem. It's just pi over 2 and 3 pi over 2. Cosecant theta is equal to 2. I like to change it to sine theta is 1/2, the reciprocal of 2. Helps me see the reference angle better. When is sine equal to 1/2 in quadrant 1? At pi over 6. When is sine positive? Quadrants 1 and 2. So your answers for theta are the quadrant 1 pi over 6 angle and the quadrant 2 pi over 6 angle. When is sine equal to radical 3 over 2? When the reference angle is pi over 3. Sine is negative in quadrants 3 and 4. So give the pi over 3 angle in quadrant 3, 4 pi over 3, and the one in quadrant 4, 5 pi over 3. Secant is equal to 2 radical 3 over 3. That's the same as 2 over radical 3 if you unrationalize it. Or you could also say when is cosine theta radical 3 over 2. The reference angle for that, the x-coordinate is radical 3 over 2 at pi over 6. Cosine is positive in quadrants 1 and 4. So give the 2 pi over 6 angles that are in quadrant 1 and quadrant 4. Cotangent's equal to negative 1. Now tangent and cotangent, we just did a speed quiz. They're equal to 1 because you got radical 2 over radical 2 over 2. So the reference angle is pi over 4. Cotangent's negative in quadrants 2 and 4. So your answers for theta are quadrant 2, it's 3 pi over 4. And quadrant 4, it's 7 pi over 4. using a calculator for these three, if you have one of the reciprocal functions, you've got to type it in like this. Tangent theta is 1 over whatever they give you here. It's worthwhile to, I think I did this in the last video. Let's see what this number is. 1 divided by negative 1.7823, so that your window is big enough. So, all right, so as long as my window for y values is between 2 and negative 2, what I normally do, it should be good. Remember, you put tangent theta into y1, tangent x into y1. Type in 1 over negative 1.7823. The window should be 0 to 2 pi. I'm in radian mode also, by the way. X scale can stay 1. Y min and max, negative 2 to 2 is good, or something that fits in this value. And you just press graph. And we just find these points of intersection. So one answer for theta is 2.630 radians. There's no label for radians. To find the other answer, you've got to scroll until you get closer to the other side. Your cursor is going to go off the screen for a little while until it hops to the other one that you can see. There it is. Enter, enter, enter. So 5.772. All right. Next one is sine equals 3/5. So no adjustment needed besides just changing numbers here. I'm just going to press graph again and find these 2 points of intersection. So one angle was 2.498 radians, and the other one, just got to get over the hump to get closer to the other point of intersection, is 0.644. This one takes rewriting. Cosine theta is equal to 1 over 0.8913. Let's see what that is. 1 over 0.8913. So that's 1.122. So our window that goes from negative 2 to 2 should be fine for the y values. So we just adjust this a little bit. This is cosine. This is 1 divided by 0.8913. And then we graph. Oh, wait, what? My points of intersection don't seem to be fitting, which is kind of weird. Oh, duh. Okay. This number isn't possible. So instead of 0.8913, I'm going to change this to, let's say, 3.8913. So we'll talk more about why that's not possible in the next section. Gosh. Okay, so this is 1 divided by 3. There we go. 3.8913. There we go. So that we actually get points of intersection. So 1.311. And the other points of intersection is 4.972. All right. Last couple of problems here. We haven't really done a lot of applications, but we should be able to. I should have been able to give this to you like back in first quarter. They give you a function. They want you to plug a number into it, and you have a calculator. So the normal daily mean temperature, T, in degrees Fahrenheit in Bakersfield, California, can be approximated by this model. T equals 1 corresponds to January. Find the normal daily mean temperature for May. So we just have to figure out what is May. So what month is May? You've got January, February, March, April, May should be the 5th month. So we're just finding T of 5. Your calculator should be in radian mode. So I don't need to graph anything. I can just type this in. 65.8 plus 18 times the cosine of pi times 5 divided by 6 minus 7 pi divided by 6. Close parentheses around cosine. I get 74.8, and the label should be degrees Fahrenheit. That's our mean average temperature over there in California for May. Okay, and then last question. If we wanted to find all values for theta, not just restricted to one circle for 21 to 29, all the ones we found angles for, how do we adjust our answers? We take theta and we add 2 pi k, where k is an integer. Think about this. This is saying, like, if one of the answers is 30 degrees, we could add 360 times k. So 30 degrees, 390 degrees, add 360 to that, add 360 to that. All those angles keep landing in the same place. So you're just finding all the possible coterminal angles. Integers are positive and negative whole numbers, so you can add or subtract to theta, and that would give you your answer. All right, that's it for this worksheet. Come see me in office hours if you need help.